Two-wheeler modeling using MATLAB. So main concept of this particular bootcamp is MATLAB. Okay. Yeah. And it will be started from the 21st of December to 23rd December. So 3 days. Okay. Bootcamps. Every day 2-hour session. Okay. From 7 to 9 p.m. evening. And during these sessions, it will cover the forces like on two-wheelers, what kind of forces like aerodynamic, rolling and planing forces. And the unit second, which will cover the making of Excel sheet, which will contain the effective forces environment. Okay. And third one is the overview of MATLAB. It's a 4 hours duration, overview of simulations and all. And then MATLAB modeling of a vehicle body, and then tire model, wind and tire effect, brake model. These kind of system because like air during these bootcamp. Okay, I'll share all the videos through WhatsApp. Okay, on the same number, you can if possible you can register by today. Okay. Thank you.
Good evening to everyone. I welcome you all to this webinar on motor drive and control. So today we'll be talking about So is my screen visible?
Yes, sir, it is visible.
Yes, screen is visible. Okay. So today we'll be talking about the motor drives and controls. Like we'll be talk about what are the different types of motor which we are using in our electric vehicles, and what are the parameters which upon which we controls the speed of the speed of the motors. So the today's agenda of this session will be the types of the motors, like what are the different types of motor we are having, and which motors are the most efficient motors which is being used in our electric vehicles. So I will show some MATLAB models of the motors, and and I will explain the working of them, and also I will explain what are the controllers and microprocessor which we are using for the control of the speed of the motors. And I will also talk about the basic principles, like what are the basic principles upon which the motors are working. At first I will talk about the different types of the motors. So first one, I will be explaining about the DC motors. So DC motors is being classified into two types. The first one is the brush DC motors, like the brushes are responsible for for flow of the current to the commutator, and then the commutator produces the electromagnetic, and then the motor causes the rotation. Whereas now talking about the BLDC motors. So just as like BLDC, from the word name we can see, we can say that this BLDC motors didn't have brushes. Actually, the rotor and the stator. So what is the construction of the BLDC motor is that the rotor has the permanent magnet fixed on it. Okay, and then the stator has the coil winded upon it. So there are Hall sensor used in this BLDC motor. So whenever the current is being flowed to the BLDC motors, what due to the detecting the position of the permanent magnet which is being fitted onto the rotors, which is sensed by the Hall sensor. So there is the commutation, or we can say there is a coil. The coil, according to that, the coil is being excited. Coil is being excited, and then the due to the electromagnetism, the so so because of that excitation, the rotor start rotating. So now talking about the AC motor, so it is being so it is being classified into three types. The first one is the asynchronous motor, or we can say induction motor. So induction motor, the synchronous motor, and the reluctance motor. So now talking about the synchronous motor and the induction motor. So the working is that whenever the three-phase supply is being given, okay, so there is the formation of rotating magnetic field, and due to the presence of rotating magnetic field and the rotor at the and the conductor at the rotor start rotating. So this when and the rotating magnetic field rotates with the speed of synchronous speed, while as compared to the as we talk about the induction motor, which we say about that is asynchronous motor. So the speed of the rotor is less than the synchronous speed. Now talking about the reluctance motor, so this is being classified into the switch reluctance motor and the SYN-RM's reluctance motor. So SYN-RM reluctance motor. So mostly Tesla are using the permanent magnet synchronous motors. So talking about the permanent synchronous permanent magnet synchronous motor. So this motors has a highly good advantage as compared to the other BLDC motors, okay, because they provide a good torque, initial torque, and the rotor gives the good efficiency and the characteristics. Now this was about the different types of the motor, and now I will be talking like what are the basic principles. So talking about the principle, like simple, we can see that the electrical energy is being given to the motor, and that is being converted into the mechanical energy, like we can see. Now talking about the Faraday law of electromagnetic induction. So what is happening in this Faraday law of electromagnetic induction? So this is the coil. So this is a coil. There is a like Faraday. He discovered that when a coil or this bar magnet, permanent magnet is bring near to this coil, okay, having any number of number and okay, n number of turns. So when this bar magnet bring near to this coil or wire, so there was some deflection into this ammeter. So depending upon deflection, we have seen that there is a electricity flown into this coil when a bar magnet is came near to this coil. Now talking about the Fleming's right hand rule and the left hand rule. So generally the left hand rule talks about the motor, like how we will decide in which direction the force will be, like rotor shaft, on which direction the rotor will rotate. So the Fleming's left hand rule talk about that. So depending upon the direction of the current and the magnetic field and the force, depending upon the direction of the current the magnetic field is being produced, the force is being identified. But when talking about the Fleming's right hand rule, so this is being like it is being talked about the generator. Okay, and this left hand rule is being talked about the motors. So similarly, we can say that for generator, the mechanical is the input and the rotor, and the electrical is the output. So from right hand rule, we came to know about the direction of the current. And now at first we we have the Faraday law, like upon what is the law on which it is the working. Now talking about the direction. Now I will be talking about like at what will be the magnitude of that particular force on the conductor by which it is rotating. So it is being given by the Lorentz. So Lorentz has been the Lorentz formula is the force is equal to BIL. So B is the magnetic field intensity, I is the current which is flowing into the conductor, and L is the length of the conductor which is inside the magnetic field. So if we apply the, suppose this is N and this is N, so this is our permanent magnet, and if we, and this is our conductor, so this conductor has the current I. So this is our magnetic field. Okay, and when the magnetic field, suppose the B direction of the B is here, and the conductor has this direction, and the conductor, the current is being flowing in this direction. So if we apply the Fleming's left hand rule, so we can know the direction of the force. Okay, so now if we put the middle finger in the direction of the current, like this red one part, and the forefinger, this finger, in the direction of the magnetic field. So this is the direction of the magnetic field, and the current is the current direction is this. So our thumb will be upside. So this is how we can see that this is the force, and now the magnitude of that particular force is being, the magnitude of that force is given by force is equal to BIL. Similar to the, if we talk about this segment of the conductor, so if we talk about the same thing we will apply here. So same, this magnetic field will be in this direction and the current will be in this direction, but if we apply the Fleming's left hand rule, the force will be downward. So for direction we have Fleming's left hand rule, for magnetic we have not magnetic, for magnitude we have Lorentz force. Okay, so now this is the basic construction, like we have the simple motor, we can say that we have the motor. Now how we will control the speed of that motor. So as we know that the motor which we are using in our electric vehicles, so these motors have a very dynamic response, like suddenly if we drive a car, okay, so we need to we will increase the speed, we have to sudden apply the brake, as the divider came, bumper came, we have to decrease the, so that process is very dynamic. So there are many sensors which is being used to control the speed of that motor. So this power so there are power devices drives, which consist of the transistor, the MOSFET, the IGBT, the GTO, and the thyristor. So depending upon the response from the controller, the the microprocessor, or the or we can say the control unit gives the command to the power electronics devices, and if depending upon that the switching is being done. So this was about the working, like how we control the motor. So this is there are current sensor also which sense the kindly mute there. So current sensor, so this one is not. काम
மதுரம் காயாதா
ஐஸ் கட்டினா கரைச்சி
எல்லாம் நல்லா கரைஞ்ச காய கட்டிக்கானா గాలి
అందులో కనవయ్య మట్టినలా తిరుమూని చెప్తారు
నాడని ఇంటికేషన్ పెట్టుకోవడానికి
So for current sensors, sorry for interruption, someone has unmuted is. So we were talking about the current sensors, so kindly ignore this part. So for current sensors we have shunt resistors, Hall effect sensors and the CT, that is the current transformer. So for sensing the current from the motor, like how much current is being given to the motor, so these sensors, like I named them, the shunt resistors, Hall effect and the CT. So this senses the current into the motor, and then according to that the processor gives the command to the power device drives, and then the motor changes its speed. Okay, now I will be talk about this processor. So this is microprocessor, microcontroller, ARM and DSP, digital signal processing. So all this, so this is the brain, we can say. So this gives the command and to the power devices drive, and then according to that the speed of the motor is being changed. Now there are the sensors, so which sense the acceleration, position, speed of the motor. So they are like tacho generators, magnetic pickup, optical disc, rotatory encoders. So these sense the variation in the motor speed, acceleration and
कर रहा है बार बार
Tadi bericap kami lagi untuk tadi.
So the speed, so the speed, position and the acceleration of the motor is being sensed through the sensors, the tacho generators, the magnetic pickup, the optical disc, rotatory encoders. All these senses the speed, acceleration and position, and then they give feedback to the processors, microprocessors and the microcontrollers, and then according to that command the power device drives give the command to the motor, and according to that the speed of the motor is being changed. So this was about the motor control block diagram. Now the thing is that the speed control. So speed control can be done through three types, like voltage control, flux control, flux and the rheostat control. Sorry, not in here, it will be armature. Armature. So these are the three ways by which we can control the speed And now for our EV application, like we have our EV will go in forward, like it requires motoring in forward direction, as well as it required braking in the forward direction, and also while the reversing in reverse order, it also required the motoring and the braking also. So for a EV motor, we required that the motor should operate in 4 quadrant. Okay, so the motor, the controller, or we can say the drives which is used for our electric vehicles should follow the 4 quadrant operation. So depending upon that, the motor runs in our EV. So for a normal speed control, so this is our, let's suppose this is our motor, and this is the drives on which we give the switching. Okay, so according to the command of the switching, this motor is being excited, or we can say that this motor is being rotated. So from this figure, we can see that if we turn on the switch 1 and the switch 4, so what will happen, and this switch 2 and switch 3 will be open. So what we will see that this switch 1, the current will flow from the positive through switch 1, and then it will be entered into the A part of the motor, and then it will be come out through this, and then it will flow through this switch 4, and then it will form a closed circuit. And then let's suppose at this instant the direction of the motor will be in this direction. Sorry, let me assume it will be in clockwise. So it will be in clockwise. Now if we now if we turn off this switch 1 and switch 4, now now this time we switch on the 2 and the switch 3. So what will we see, the current will enter into this from B terminal, and then it will came out from the A terminal. So at this instant, the rotor will rotate in opposite direction, because the polarity of the, or we can say the flow of direction of the current is being changed. So this is how by switching we control the speed, or we can say that we control the direction of the rotation of the motor. Okay, so this was about the introductory part of the speed controls. So now I will show you the MATLAB demonstration, like in MATLAB how we can design the motor, and how we can control the speed, and how we can change the direction of the speed. Okay, so let me open the MATLAB file. So is my screen visible?
Yes, sir.
So this is the MATLAB demonstration of a DC motor. Okay, so this is the MATLAB Simulink. On this Simulink, we design a software. So it is a software on which we design the hardware. Like suppose it is just a software implementation of the hardware model. So the using of the benefit of this MATLAB is that we save the time, we save the money, and we can use the different component accordingly. So now this is the MATLAB. So this is the DC machine. So we can simply go to the library browser. Okay, and here we can see the different toolbox which we have in this MATLAB Simulink. So if we download the MATLAB Simulink, we can get this toolbox. Okay, so for designing this DC machine, DC is like DC speed controller. So simply we can write that DC machine, and we can get this toolbox. Okay, so here are my parameters. I can configure, I can change the parameter according to my requirement. Okay, and then we can set the data. For this I have chosen the 240 volt for armature and the 300 volt for the 300 volt for the field. Okay, so here I will. Okay, so this is the field current, this is the armature. Okay, so for 300 for field I have chosen a DC voltage source, so I have given the amplitude of 300 volt. Okay, and this is the armature. So by changing the armature voltage, I will be varying the speed of my DC motor. Okay, so this is the drive on which I have connected the switches. So I will, as in the presentation I showed like how these switches are responsible for changing the direction and the speed of this motor. And now the main signal which we are giving to this driver circuit, or we can say this MOSFET switching combination, is from the PWM, like pulse width modulation, and depending upon the PWM response, the switch is being excited for a while, or we can say for a particular time. Okay, and then the motor will. So here for armature it should be 240. Yes, it is 240. And for this repeating sequence I have chosen the values 0.5 and 1. Okay, and the output values is being given 0, 1, 0. So covering a reference value, or from a reference paper, or we can consider a reference book for in which the demonstration of this MATLAB is being given. Okay, according to that we can take these values. Okay, and we can build our own logic. So here we can see that this is the PWM signal, and I have given the sequence, and this is the comparator in which I have a relational operator in which I have taken the less than greater than value. Okay, and then this signal is being given to the switches. So what I do, suppose this is switch 1 and switch 2, and this is switch 1, switch 4, and this is switch 2 and switch 3. So I have given the same command to the switch 1 and switch 4. Okay, as I explained in the PPT, and then the opposite of this both switch command, this is being given to the switch 2 and the switch 4. So this is the circuit diagram I have designed. Okay, we can design through it, and this is the scope, like what is the magnitude of the speed, or we can say in which direction the magnitude of the speed is being given. So everything is being done here. So when I take this, a stop time I will take at 50 seconds. Okay, and then I will run the simulation. So what I see, the model will start running, and then we can see that the motor is rotating at the speed, because at this instant I have put the speed. So this one at the top of this scope. So this is talks about the speed. Okay, so this is about the speed. We can see the speed is being given here. So we can change the background also. So we can see how we can vary the speed, and the speed of this DC motor at this for 50 seconds it is giving approx more than I think 1750 RPM. So what I did here, if this is the gain, so this gain I have used for converting the radian per second value into the radian per minute value. Like to convert the radian per second into per minute, I simply did 30 divided by pi, and after that I will get the radian per second value into the radian per minute. Okay, so now the second layout of this scope will give me idea about the armature current, the field current, and the electrical torque. So we can perform various things. Okay, depending upon that we can get the required. So here I have taken the 0.9. Okay, and at this time the speed is being in positive direction, like the rotor is rotating in the positive of the positive 1700. Now when I decrease the value, like I have taken in the repeating sequence as the medium value 0.5, so if I decrease the value below 0.5, so what it will be, it will be, now I run the simulation. So what I see, the rotation direction is being changed, so it is in the reverse. Okay, now the rotor is being rotating into the negative, like it is now rotating in the opposite direction. So this is how we can explain or we can explore this MATLAB, and we can perform various tasks. Okay, so this was all about the drives, and we can see the demonstration of the drives on the MATLAB. Okay, and because of this drive we can vary the speed of the rotor. Okay, so that was from my side. So any question?
Yes, there is a question from my side. Am I audible?
Yeah, you can ask.
Yes, I think this is the open loop control. What about the closed loop control?
You can refer a reference paper, and according to that, referring a reference paper, we can design. We can design, because I cannot explain all the things like closed loop and open loop in this single video. Okay.
Okay, no problem. And is this voltage control method or the flux control method?
It was armature.
Okay, thank you.
Yeah. Hello, am I audible? Thank you everyone for joining with us today for this webinar on
Thank you everyone for joining with us for the webinar on the electric motor drives. So if you want to learn more about electric motor selection, designing, industry prospect, we have the specialization course in EV. Under the course, you can learn various topics including about EV industry, powertrain calculation, aerodynamic calculation, wheel selection, motor selection, various motors in electric vehicles and control methods in EV. You can also learn about theory of motor designing, motor modeling, and energy consumption of motors. So under this course, you will learn about principles of motor, powertrain calculation and selection, various motors in EV, and the most important is motor modeling using ANSYS, MotorCAD, and MATLAB. So this course is of 20 hours of self-learning modules and delivered by the industry experts. Also, the course fees for this course is 8,499 rupees. You can visit our website at www.isieindia.com and you can learn more about the courses. I'm also sharing a link here where you can put the inquiry if you want to learn more about the course. You can find the link in chat box where you can fill the details and our executive or admission council. You can find the link in chat box where you can put your queries. So our admission counselor will get in touch with you and they will give you the overview and the description about the course. Everyone, please find the link in chat box. You can put your query over there. Thank you, Harsh, for your feedback. Atik, we will share the certificate shortly with you over email. Thank you for joining with us today. Thank you, Naveen, for your feedback. Thank you, Thiriva Lavan, for your feedback. Thank you guys for joining with us today. Tanmaya, you will get the reference link. I'll ask the expert to share if they have the link of the reference paper. So they will share with you. Thank you, Kuldeep, for your feedbacks. Thank you, Atik. We'll try to share the documents with you if possible. Thank you, Shankar, for your feedback. Thank you, Chetan, for your feedback. Thank you, everyone. Thank you, Ankit, for your feedback. Please make sure to fill your query in the link given in the chat box so that you can learn more about electric motors. Yeah, Harsh, the certificates will be issued through email. Thank you, Antonio. Thank you, Akshay. Thank you, Kishore, for your feedback. Thank you, Shaka Ashwardhan, for your feedback. Thank you, Durga Divya, for your feedback. Guys, if you more want to learn about electric motors and powertrain selection, you can join our course. The query link is given in the chat box. You can join. You can fill your queries. Our executive will connect with you. Thank you, Ranjan, for your feedback. Thank you, Devesh, for your feedback.